Hey, Max Matthias here. Chances are that if you have seen my channel before, you have probably seen it due to the Can You Do an Econ PhD video. I hope that has been very helpful for those of you who have watched it. I thought that, part of, as I mentioned during that video, prepping for a PhD in econ is to take the GRE. And as I mentioned in that video, it's quite unique for the Econ PhD that all that really matters is your score on the quantitative portion of the GRE. So, what I thought I would do tonight is go through some GRE practice problems, focusing on the quant, of course. The reason for that is back, 12 years ago now when I took it. Not to brag or anything, but I actually got a perfect 170 on the quant portion of the GRE. I think that was basically due to A, I studied a lot, also B, there's a little bit of luck in there. So hopefully this video, me going through answering some of these, walking through my reasoning, will be helpful for you. If you're doing an econ PhD, you probably already know this stuff. If you're not, then I think this will be more help for you. So let's get into it. Okay, so we have a challenge problem. So these type of problems here, I wanted to do this one first and try and actually focus on this one more. I think this is the most common type of question you will see on the Math GRE, and I also think it's one that you can game the system a little bit to make your life a little bit easier. So the way these type of questions work is it will give you two things, quantity A, quantity B, and these four choices are always the same. Quantity A is greater, quantity B is greater, the two are equal, or D, the relationship cannot be determined. Now, this is where I want you, in kind of prepping for the exam, D, the relationship cannot be determined from the information given, that should be your default. And that is what I find that most of these questions are. That's not to say all of them are, but most of them I think are D, and you're really just looking for kind of that one thing that breaks what kind of intuitively you think it should be. So I find these questions, A or B, intuitively you think is bigger, or maybe intuitively you think they're always equal, but there's like one kind of edge case where it flips, and that's why D is the right answer. So let's walk through this. I also will be overlaying me doing any hand notes if I have to. Hopefully I can head math this. So here we have a driver completed the first 20 miles of a 40-mile trip at an average speed of 50 miles per hour, and the second 20 at an average of X. The average speed for the entire 40-mile trip was 60 miles per hour. They didn't make any stops. And then what it wants to know is 10 or is X minus 60 bigger? Okay, so what we need to do here is there's going to be factoring in time, right? So on my notes here, we do first 20, as I'm moving my notes, hopefully, miles at 50 mph, excuse me. And so what that means is that let's break that into a time. And we need to know then the average speed was 60. So 20 miles at 50 miles per hour, let's break that into a time, right? So 50 miles per hour, right? We want to somehow get that into a time that how long would it take you to do 20 miles? And the answer is you would just go 20 over 50, right? 20 miles over 50 miles over hour. When you do that math, you would get that is 2/5 of an hour, or however long that is as far as that 24 minutes. And then the second 20 is an average of X, and then we know that the average speed for the entire thing was 60. Okay, so what we know then is 2/5 times 50, which gives you your 20 miles there, plus there's going to be some time that they were going times X, is 60. mph. Now, one thing that you can basically do is let's assume that it was 70, because that's really where they want you to go here, is what if x was 70 miles an hour? That's kind of the knee-jerk reaction. So if we plug in 70 for that second miles per hour, right, we go ahead and do that. That's 20 miles at 70 mph, which is then 2/7 of an hour. And when we actually do that kind of time weighting, right, which is, for 2/5 an hour I go 50, for 2/7 I go 70, does that actually lead me to an average of 60 miles an hour? And the answer there is going to be no, right? It's not balanced between those two. And the way you can kind of see that is to get kind of an average speed that you were going over those things. I mean, so all of this math right here that I'm kind of doing is to say that A is going to be greater. It has to be. Because for you to average 60 miles an hour, you have to be going over 70 miles per hour, because you have to factor in also that you were going to be taking less and less time as you go through that.
Max here. I kind of brain farted on the solution to the 50 and 70 mile per hour problem to find why it actually has to be greater than 70. So let me quickly walk you through the math here. So here you can see, as I have written in the notes, 50 miles per hour, we spend 2/5 of an hour doing that, right? That's just taking the 20 miles divided by the 50, and then 70 miles per hour is 2/7. So I was trying to get to this, but for some reason, brain just didn't work. So what you then want to do is add those two fractions together, as you can see right here. So 2/5 plus 2/7, when you find that common denominator of 35, gives you 24 over 35. So then what you're going to do is multiply each of those respective fractions by the reciprocal, 35 over 24. And the reason you're going to do that is that then gives us basically, if we were to continue that kind of time split, 2/5 of an hour and 2/7 of an hour at 50 and 70 miles per hour respectively, this basically would allow you to convert that into 20 miles per hour. So 2/5 times 35 over 24 is 7/12, and then 2/7 times 35 over 24 is 5/12. So this is the 70 mile per hour time, and this is the 50 mile per hour time. And now we can do the last step, which is taking 7/12 times the 50 miles per hour plus 5/12 times 70 miles per hour. That gives us 700 over 12. And when you simplify that fraction, you get 58 and 1/3 like I have here. So as I had mentioned in the video, the reason why x must be bigger than 70 is because when we are traveling at 70 miles per hour, we are necessarily traveling a shorter time thing because we have a fixed distance. And that's why that kind of knee-jerk reaction of just looking at the averages 50 plus 70 divided by 2 doesn't work there. And there's actually kind of a riddle question that uses this before we get back to kind of quant GRE things. And so the riddle goes something like this. You're making a 40-mile round trip, and so you're going to break it into a leg of, say, 20 miles going to point A and then 20 miles going back to where you started. And let's say it takes you an hour to go those first 20 miles. So that first leg of the trip, how fast would you have to go on the second leg to average 40 miles an hour over the entire trip? And that's another one where knee-jerk, you just want to kind of say 60, but actually it's impossible to go 40 miles an hour because you already took an hour for that first leg of the trip. Any additional time it takes you, no matter how fast you drive the 20 miles an hour back, you are covering 40 miles in over an hour, and therefore on average your speed is less than 40 miles an hour. Okay, here's an interesting one. So we have x is chosen at random from the set 1, 2, 3, 4, and y is chosen at random from the set 5, 7, 9. Now, the probability that x times y will be even, that's A, and then B, the probability that x plus y will be even. Intuitively here, remember, so for something times something else to be even, one of those two things must be even. So basically, what A is asking us is, since y is odd, that's, don't worry about that right now, but then, so it doesn't matter what we pull from y,
What matters is that what we pull from x is going to be even. It must be. So it must be 2 or it must be 4. Now here's the interesting one. The probability that x plus y will be even. Well, the only way that you can get two numbers, and if one of them is odd, then the only way that you can get the other one to be odd is, the only way that you can get their sum to be even is the other one must be odd as well. And the way that you can show that real quick is, we'll kind of do this. This isn't math that you would be doing, but just to kind of show you. We can call any odd number can be called 2k plus 1, where k is just some non-negative integer. Usually we define it to be strictly positive, but 1 works. So then even numbers, we can always then, what makes a number even is that it is divisible by 2. So we just write it as 2k, where k in that case. We can also say that because technically 0 is even, but let's think positive numbers. As you can see then, if we have this multiplication happening, right? So let's say x is even, and y, which we know is odd no matter what, x times y we can write as 2k times 2k plus 1. You could substitute it in a different number here if you don't want to worry about it. But the idea is that here's you would get 4k squared plus 2, or 2k squared plus 1, and then just call this something else, right? You can just call this, say, j, and that's 2j, which is even, right? This is going to be an integer. We're good to go. So this basically shows that, and then if you had an odd, there would still be a plus 1 hanging around. So that's why that can't be even. And then when they're added together, it's basically the same thing, right? X plus y. The reason why we must have odd numbers is we have 2k plus 1 plus 2k plus 1. We can just call that, in this case, 4k plus 2, and write it the same way, right, as 2k plus 1, and just call that j again. So 2j. So really what matters here is how many even numbers are in x and how many odd numbers. And since it's split down the middle, right, basically drawing from y does not matter here. So these are going to be equal, and the reason why is because it's all dependent on what we draw from x, and since there are 2 even numbers and 2 odd numbers, these are going to be equal to each other. Okay, so here we have an interesting one. This is strictly negative numbers. 0 is less than p, which is less than q, which is less than r. It is asking us if p over q, to compare that to q over r. So let's see if we can find a way to break this, because remember, now that we are in negative world, these are going to be positive fractions, right? A negative divided by another negative is positive. And all we need to do is find the thing that breaks this, more or less. So the first thing I'm kind of going to here is say p is -1, q is -2, and r is -3. And when you do that, you will get 1/2 and then 2/3, which this is bigger. But let's say I make r, right, so if we hold these two constant and then change r to be, whatever the hell we want, say r is -10, then this is still 1/2, and then we have 2 over 10, in which case this is bigger. So immediately to me, this is a D, particularly because all of these necessarily have to be positive. Okay, so here we have an interesting one. Car A and car B are at the opposite ends of a straight road. Car A moved towards car B for basically half an hour at a speed of 40, and then car B starts moving towards A at a speed of 80. Both cars keep moving towards each other, maintaining their respective speeds until they meet. Okay. I can already tell this is going to be D just because we don't know how long the road is, right? They don't tell us. So sure, like car A gets a 20-mile head start, and so if the road is, say, 30 miles long, just kind of doing this, there's nothing to talk about here. But if, say, the road is 200 miles long, then B obviously is going to travel more. So this is one where they're not giving us the critical bit of information, which is that how long is this road? Yeah. Here's a word problem, but still is following the same formula. So Jacqueline traveled from New York to Virginia in 2 legs. She traveled more miles in the first leg than the second leg. Okay. And she drove for 4 hours for the first leg of the journey and 3 for the second. Ignore any stoppage time. Average speed for the first leg, average speed for the second leg. This still feels like an unknown, and here's why. All we're given is, so let's call the miles that she travels in the first one to be M1. We know that's more than M2. We also know it took her more time for the first, right? So basically T1 is 4 while T2 is 3. And then it wants to know the average speed, right? So that's basically going to be M1 over 4 comparing M2 over 3. As long as, obviously it's talking about New York to Virginia, but it doesn't give us a total distance that she is traveling. This first leg could be like 100 miles, in which case that's 25 miles an hour, while this second one could be 10, in which case she's going much slower, right? They don't give us any more information. On the other hand, it could be, say, 1 mile more, and then she spends less time. So this is another one, D, just because they're not giving us that critical bit of information, which is how far was each leg? So we have the area of a square equals the area of a circle. So area of a square is side times side, which is S squared. And then it's basically saying the area of a circle, remember, is pi r squared. So if these two things are equal to each other, the circumference of a circle is 2 pi r. So basically we are given 2 pi r. We're comparing that to the perimeter of a square, which is 4s. And I'm trying to back out what relationship is between those. Now, what we can basically do is, if we know that these two things are the same, right, the area of a square equals the area of a circle, we then know that s squared, since it's equal to pi r squared, s is going to equal square root pi r squared, or s must be then square root pi just times r, bringing r out since that's squared. Whenever you have a multiplication inside a square root, you can separate those, but not addition or subtraction. So just be careful. Multiplication, division, you can mess with those in square roots. You cannot do addition or subtraction. So then 4s is 4 times root pi times r, compared to the perimeter of a circle, which is 2 pi. And then if we wanted to basically get s squared equals pi r squared, we could just solve this for that. We'd have s over root pi is r, so then 2 pi r would be 2 pi s over root pi. So that's basically 4, whoops, that's not a 4, 4 square root pi r, which it already just feels like we're asking we probably don't even need to do this last step. So let me actually erase this crap because I don't need it. We're asking which of these is bigger. Basically, we're saying r is 4 root pi r. How does that relate to 2 pi r? And let's check this. If we basically, square root of pi, okay, all we have to do here is pi is 3.14, which is fine. This feels like it has to be bigger because the square root of pi is going to be 1 and change. Now, this is basically boiling down to, is 2 bigger than or equal to the square root of pi? And the answer is 2 is bigger than the square root of pi, so then this left side is bigger, so then the perimeter of the square is bigger. Set A arranged in ascending order of the values. Okay. The mean or the median. Okay, so remember the median is if you start from the sides, you start to kind of move in. So I would take minus 10 and 14 away, minus 7 and 2 away, minus 5 and 0 away. So then it's basically the median of our thing is going to be, and since x is negative, basically it's going to be, x minus 2 over 2 is our median. So x, the median does change here. Now the mean is, let's work this out. We have 8 data points, and we're starting to add things together here. So what I can start to do is to make this algebra easier. This minus 2 and this 2 cancel. The 0 doesn't do anything. So all we have is minus 10, minus 7, minus 5, and then basically plus x, and then plus 14. But don't even worry about the plus x for now, 14, right? And this minus 10 and minus 7, that makes that minus 3, so that's just minus 8. And then when we, so it's minus x plus that over 8, or x over 8 minus 1, while this is x over 2 minus 1. Because x is negative, we have a negative number over a thing. So a negative number over a bigger thing makes it less negative. Like negative 4 over 2 is negative 2, while negative 4 over, say, 8 is negative 1/2. And so in this case, I think this median is always going to be bigger than this mean. So I think median, oh no, greater. Mean is bigger because we're talking about negative numbers. So mean must be bigger because it's a negative number divided by 8. That gets us closer to 0. Okay, so a trader purchased a few books such that each cost, hold on. Okay, a trader purchased a few books such that each cost an equal amount, and then each sold each of them an equal. This is like god awful English, right? This feels like ChatGPT wrote this. Okay, profit if the selling price is increased by 20, or increased gross profit if the selling price is increased by $20. This is another one where it has to be this, just because. So remember, Econ 101 here, right? Profit is revenue minus cost. Revenue is always price you sell it for times Q minus whatever your costs are. In this case, costs are basically undefined, right? Each cost an equal amount and then sold each of them at an equal price. If the selling price is increased by 20%, so basically that's saying, what if I could take this P and multiply it by 1.2 PQ? These, since costs are unchanged, it's basically asking, is this bigger, right? 1.2 times P times Q, and I'm assuming we're holding Q constant here, or increased gross profit if the selling price is equal more than 20, that's basically P plus 20 times Q. And the answer is, it depends on P, right? If P is 100, these are exactly the same. If P is less than 100, B is bigger. If P is bigger than 100, A is bigger. So D must be the answer. This one, let's see. Okay, I think this one visually is kind of intimidating, but we're going to work out a pattern here and kind of work. So A1, A2, A3, all the way to AN, right? They give us the first one. So A1 is minus 2. A2 is minus 5. A3 is 4. A4 is 3. Okay. And then it says AN equals AN minus 4 for n bigger than 4. So I think they're trying to hide you here. So basically what it's saying is like A5 would be A1. So then it repeats, right? So A5 is -2. A6 is -5. A7 is 4. A8 is 3. Now, what I want you to realize is in these blocks of 4, these things basically add up to 0, right? We have -7, and then we add that. So this sums to 0, and this sums to 0. So when it says the sum of the first 64, all we're really looking at is this thing divisible by 4? If the answer is yes, cool, then it's 0. If it's not, it has to be negative because we are adding on those positive numbers in the last 2 steps. So is 64 divisible by 4? Yes, it is. So that is going to be 0. Is 98 divisible by 4? The answer is no. That is actually -7 because 100 is divisible by 4, so we are only including those first 2. So it must be the case that A is greater because these things just add up to 0 again and again and again. And there we go. That one wasn't too bad. Okay, so I hope that was helpful. If you'd like me to do another one of these in the future where I do different types of quant GRE problems, let me know in the future. I'll see you next time.